So let's say we have this problem and we solve it using the big M method. So for the second constraint C, it's simple. We just add a slack. So if we add a slack, say S2, this becomes equal to 7. For the third constraint, subtract a surplus and add an artificial to convert it into equal to. What is the first equation? First is x1 plus 2x2 plus x3 is equal to 5. So should we need an artificial variable in the first constraint? See, x1 is in all the constraints, so leave this. x2, all the constraints, leave this. But see, x3, it is with a positive coefficient. Right hand side is positive, but x3 is not there in any other constraint. So that means x3 can start. So we need three basic variables to start. And what are those three basic variables? x3 will start, this slack, and this artificial. So SIs are non-negative. The artificial variable A3 is non-negative for all I, and XIs are already non-negative. The objective changes. Objective becomes minus x1 plus 2x2 plus 3x3. This is the original part, and the penalty term is maximization case added only a single artificial variable. The penalty is minus m into A3, where m is positive, m tends towards infinity. Okay. So now we make the table. So the variables are CB, basic variable, x1, x2, x3. Then we have S2. Then we have S3, A3, RHS, and theta j. So this is the variables that we have. The coefficient are 1, 2, 1, 0, 0, 0, 5, 1, 3, 0, 1, 0, 0, 7, 1, 5, 0, 0, minus 1, 1, 11. Basic variable is x3, then S2, then A3. Above we write minus 1, 2, 3, 0, 0, minus m. So x3 का है 3, 0, minus m. Zj minus Cj is the first value is 3 minus m plus 4. The next is 6 minus 5m plus 6 minus 2, 4. The next is 0. S2 is 0. The surplus is m. Next is 0. Now we are solving a maximization problem. So what variable enters? The most negative enters. So this is most negative. For the minimum ratio, the ratio is 5 by 2, 7 by 3, 11 by 5. So the minimum ratio is, this ratio comes out to be 2.2. This comes out to be 2.3. This is 2.5. So the minimum is this. So the minimum is 11 by 5. The pivot is 5. Now we extend our table. So x3 stays, S2 stays, A3 moves out, and x2 comes in. x3 का 3, S2 का 0, x2 का you have पिवट को 1 बनाना है, डिवाइड थ्रू आउट बाय 5। यहाँ पे 0 बनाना है, so multiply the changed R2, multiply the pivot row by -3, add it to the second row. So -3 by 5 plus 1. So that is 2 by 5. This is 0. This is 1. This is 3 by 5. This is -3 by 5. And this column is -33 by 5 plus 7. 7 minus 33 by 5. So that is 2 by 5. Now to make 0 there, what you do? Multiply the pivot row by -2 and add it to the first row. So this value is 1 minus. So this value is 1 minus 2 by 5 is 3 by 5. This is 1, 0. This is 2 by 5. This is minus 2 by 5. This value is 5 minus 22 by 5. That is 25 minus 22. That is 3 by 5. Okay. Now we calculate Zj minus Cj. The value is 9 by 5 plus 2 by 5 is 11 by 5. 11 by 5 plus 1, because minus of minus 1. So that gives you 16 by 5. The next is 0. The next is 0. The next is 0. The next value is 6 by 5 minus 2 by 5. So that is 4 by 5. The next is minus 6 by 5 plus 2 by 5. So that is minus 4 by 5 minus of minus m. So m minus 4 by 5. Now we calculate the z value because there is no artificial variable. So the z value is 9 by 5 plus 22 by 5. So that is 31 by 5. The Zj minus Cj has all non-negative entries. This implies optima reached. For a maximization case, this is the optima. And what is the point of optima? The point of optima is x3 is 3 by 5, x2 is 11 by 5, s2 was what? S2 was the slack in the second. S2 is 2 by 5. What is x1? See, x1 is not found here in the basic variable column. This implies x1 is non-basic. So the value at the optima is x1 is 0, since it is non-basic. Non-basic are by default at 0 level. x2 is 11 by 5. x3 is 3 by 5. Z value is 31 by 5. So this is the optima. So we have used only a single artificial variable and we have solved. See, you can use 2 artificial variables also, but then it would take more time to solve. And it is also better if you use less number of artificial variables.